and posted to YouTube. I'll just start by reminding you that tonight's the first night that there's homework due online. So 2.1 and 2.2 are due this evening at midnight. Looking at those homeworks, it looks like about half the people have completed both of them, and maybe half the people haven't started. So if you're in the haven't started boat, Godspeed to you. No, I'm just kidding. I'll be around tonight, but the point of this is hopefully you look at it before these sessions. So if you have questions, we can answer them together here rather than me answering 100 emails on Wednesday nights. But anyway, it's the first Wednesday they're due, so we'll see how it goes. We also decided last time that we'll have our first test on Wednesday the 15th. And I've updated the topics to include sections 2.1 and 2.2. And I included a review sheet that I got from another linear algebra professor. So it's not like a comprehensive review sheet that is the only thing you should study, but it's like a nice review of terms and some practice problems and things like that. Keep in mind, like the problems out of the book that the answers are online for are also good problems to look at, to study as well. Okay. I think that's really all I wanted to sort of open with. I didn't get any specific email questions. The section for today was supposed to be 3.1 and 3.2, which was about determinants. And I'm happy to answer questions about the notes if you have them, or if you would rather talk about homework or a past section, that's fine too. So what can I do for people today?
I have a question about the 3.2 homework.
Sure.
I think it was question 2, and there was the second sub question in question 2. It's asking for like the determinant of 3 times the determinant of 3 times a, and like it gives you the determinant of a, which is -1.
Yep.
But the answer is not -3; it's -9.
Who is talking? Is this Thomas TJ talking right now?
No, this is William Robinson.
Okay, yeah, we emailed last night. Did you get my response?
I don't remember sending you an email about this.
Emailed to someone about this one.
That was me, Joe.
Oh, it was Joe. Okay, sorry about that. So yeah, Joe had caught that error, or it looks like a couple people caught the error, and there was an error in the solution. And so I went ahead and edited that, and it should be all set. Did you say it was 3.2?
Yes, it was 3.2.
I think that's the one Joe was talking about. Is that right, Joe?
So what's the real correct answer then? Is it?
It should be -3. It should be -3. And it looks like Williams got that one correct, and it looks like TJ needs to probably resubmit. It looks like TJ was banging his head against the wall on that one a little bit. But I think you have the right idea, and it should be corrected now. Yeah, I'm sorry about that. It looks like Sydney as well had been trying that one and getting it wrong, so Sydney should probably resubmit there. The way that these homework problems are created is they're created by people around the country, and I choose them from a database, and then I can edit them and things like that. But when problems like this crop up, the first time I use them, they're gonna crop up, I guess is what I'm trying to say. So keep those sort of questions coming. I can go in and edit things, like I said, and try to make things more clear and whatnot. So apologies, but thank you for catching that one. Let's see, there's a question here I didn't notice. Is there an easier method to get, so Brendan asked, is there an easier method to get the determinant of a 3x3, or is it just memorization? So you don't have to memorize anything. You just need to expand around any row or column. And so let me pull those notes out real quick. I think what you're probably referring to in terms of memorizing might be that complicated looking formula. Let me pull the notes out here. So like you're referring to the determinant. So this is page 2 of chapter 3. So page 2 of the determinant section. Did I post chapter 4 yet? Let me just double check to make sure the notes are posted. I just wanted to. because we'll be getting into chapter 4 here pretty soon. I did post chapter 4. Okay, I still need to post chapter 5. So anyway, this is page 2 of determinants. And the idea is if we have a 2 by 2 determinant, it's easy to do because you just use this formula, right? So if you have a 2 by 2, just use the formula, no big deal. But when you have something bigger than a 2 by 2, like a 3 by 3, for example, you need to expand around one of the rows or the columns. And I'm assuming Brendan's sort of wondering if this is something that needs to be memorized. And so, yeah, I mean, in some sense, you need to know how to do it. But I wouldn't recommend like trying to memorize this complicated looking expression. I would try to just remember the process that you do it. And so the process that you do it, let me just summarize real quick. Let me get the next page to summarize this one. Is you want to pick a row or a column that has got a lot of zeros in it. And so that's why I chose this column, because it has a 0. And then you pick the elements out of the column, right? So you do like 1, you pull that one out, 0, you pull that one out, 1, you pull that one out. And so those become the coefficients that multiply each term. And then when you pull one of the elements out, you delete that row and that column and then do the determinant of what's left. So like when I pulled the 1 out of the first row, you delete that column and that row. Here I am deleting those. Oops, snuck out. Right, and you're left with, when I deleted those things, you're left with the matrix 5, -3, 2, 3. And so that's why this matrix right here is 5, -3, 2, 3. Right, because that's what's left when you delete that row in that column. And so that's what that formula says, but it's like, again, it's not like something you need to memorize necessarily. You just need to realize what the process is. And the plus or minus part of it is just what it says in this bottom right part. Like when you pull something out of the upper left-hand corner, it gets a plus sign, and then you just alternate moving across the matrix. So like on this example, when you pull the 0 out here, it gets a plus, the 4 gets a minus, the 1 gets a plus, the 5 gets a minus, plus, minus, minus, plus, so you just like alternate as you pull them out. And I would, this is the kind of thing that I remember being really kind of overwhelmed by when I first learned and I first saw the process and the formula and things like that. But it's the kind of thing that once you do a couple of problems, it shouldn't be terribly horrible. And so maybe that's a good time to sort of mention that now that we're moving into this online homework, and I'm not necessarily going to be collecting your work, it's important that you still write your work down and you show your work. The whole point of me like busting your butts about showing your work and justifying your answer and things, and I would say, oh, it's so I know you're not cheating out of the back. Like, yeah, that's true, but it's really so that you can practice writing mathematical arguments, and so that when test time comes, you have nice solutions to your own solutions to look at. Like, that's the whole point of writing solutions, really. I just sort of mask it and say, oh, you need to prove to me you're not cheating. And so, the idea is when the test time comes, you want to have some nice practice problems to look at. And so you should write your answers down in a nice way so you can go back and look at them. And I'm sure most people are sort of thinking, yeah, I know that. But if you're the kind of person that's just trying to get through these homeworks without doing any work or doing the least amount of work, it just might come back and haunt you a little bit when it comes time to study. That's all I'm trying to say. So anyway, that was a long-winded answer for that question, Brendan. Is that sort of the thing you were talking about? Did what I said help at all? Is there anything anyone wants to add to what I just said about determinants? I'm like happy to do one. We could do one from the homework if you want or something like that. Or you're welcome to ask another question.
Can you hear me?
I can hear you.
I wasn't here during the last session, so I have to ask, how are you gonna give us a test? Are you gonna like email it to us, or do we have to like print it out ourselves?
Okay, so a couple things. I also see the questions coming in the chat. I'll answer those in a second. Let me address what I believe was Adrian. So first, if you ever miss a session, I'm recording this right now. I post all these sessions on YouTube. So if you miss one, you can go back and watch it. Or if you want to like hear me say what I said about the test again, you can go and watch that. But I'll reiterate it now anyway. But just know that moving forward, I always post these things on YouTube. So what's going to happen is I'm going to invite you to like a Zoom meeting, probably either Zoom or Google Meet. I haven't decided, but I'll invite you to some kind of video chat. You will set your computer up or your phone or some sort of camera so that I can sort of watch you take the test, right? So it'll like be an image of you at your desk. And then I'll email the test out. You'll pull the test up on your computer, and then you can just write, do the test on like blank pieces of paper while I watch you via webcam. I'm considering letting you guys use some notes and things like that, and so trying to make it like a low stress thing, but I also want to make sure people are just doing their own work is really the short of it. And then when you finish, you'll scan them using the cam scanner app, and you can send them back to me. That's the way it's going to work. So I saw the other couple questions here in the chat as well. Let me address those. So Sydney, yes, we can do one of the homework problems. Let me see what Brendan said. Yes, my method was writing the formula every time, so thanks for pointing out the pattern. Yeah, so, and try that pattern a couple times when you're doing a few of the homework problems, and you'll see that just kind of doing the pattern and following the steps is easier than trying to write the formula out. I try to write the formula out just to like help you make sense of the formula and give you an example of the formula sort of played out. But yeah, it's not something you necessarily need to write out. So Sydney asked about 3.2 number 1. Let me pull that one up real quick and we can look at it. Okay, so 3.2 number 1 looks like this. I just want you guys to know my back is like broken. I feel my back out and I can barely move. You would laugh so hard if you saw what I look like right now. I'm like leaned over in my chair in a lot of pain. So if you hear me grunting, that's what's going on here. So 3.2 number 1 has this matrix. Let me slide this down. It's got a 3x3 matrix that's got a lot of zeros in it. And yours might look different depending on how yours was generated. This is what Sydney's looks like, I believe. And so the question is, find the determinant. Does it have an inverse? And so if, when we're doing determinants, we want to pick a row or a column that's got a lot of zeros, because it makes our life easier when we do that. And so just since Sydney asked us one, it looks like she's tried it. What did you choose as a row or a column? Oh, you reduced it first. Okay. So you're welcome to reduce it first if you want, but I would, and then you would need to use like those properties, which is an okay thing to do. What I might recommend doing, oh, I'm actually seeing another way to do this one as well. Does that right? So, okay, so you could reduce it, and I think reducing it would just be a matter of switching the rows around is what I'm sort of looking at right here. Right, you could basically put row 2 and switch rows 2 and row 1, and then switch those rows with row 3, and I think it would be in reduced form. It would at least be triangular. And then when you did that, you would multiply the determinant by -1 twice. So let's do this one twice. This is a nice one because we can illustrate 2 different methods of doing it. And so maybe method 1. Let's pick a row or column. Let's just do it sort of the brute force way first, if you don't mind, Sydney, and then we can reduce it. And so a nice thing to do then would be to pick a row or a column with lots of zeros. And so like row 1 or column 2 are good options there because they have a lot of zeros. And so I'm going to use row 1 just because it's row 1. I don't know why else. Is it like particularly blurry? I feel like it looks kind of blurry on my computer. You guys able to see that? So I'm going to use row 1. and I'm going to pick out the 0, and the first entry gets a plus sign. So it's like a plus 0 out of the first row, and then I delete that row and that column. And so then this is what's left when I do that. And so then I'm going to multiply that by the determinant of 0, 4, 4, 0. And then I'm going to pull the second 0 out, and that gets a minus sign because it's the second one. And then we delete the second column of the first row, and you're left with 3, 4, 0, 0. And then I'm going to pull the 3 out, and that gets a plus because we're alternating pluses and minuses. And then when you delete that column and that row, you're going to multiply it by this determinant. And so the whole point of doing that is because these two just go away because you're multiplying by 0, right? So it doesn't even matter what these other determinants are. You're going to cancel them out anyway. And so it really just boils down to this one. And that's nice and easy to do. You would just do AD minus BC. And so it'd be 12 minus 0. And so that's going to be 36. And so I believe the answer to this determinant is going to be 36. Let me double check the answer here. I did not get that correct. What's going on here? This one also incorrectly entered. Ow. I'm just double checking the answer here, folks. If anyone wants to chime in, be my guest. It's a 2 in the upper right. Adoy. Thank you. So this should have been a 2, which means we pulled a 2 out, which means this is 2 times 24, which means, 2 times 12, which is 24. And that is what the answer says. Thank you for catching that error. That's doing it like just using the definition of determinant, sort of the thing that I was talking to about with Brendan a second ago. If there are questions about that, let me know. Otherwise, we can do the method 2. So method 2 would be reduce the matrix first, and then apply some of those properties that we know from 3.2. And what I mentioned was you can get this into reduced form just by switching some rows around. And so I think you could just switch row 1 and row 2, and then switch the new row 2 and row 3, and it would be this matrix. It would be 3, 0, 4, 0, 4, 0, 0, 0, 2. Let me just pause there and see if that looks okay. If anyone has any questions about what I've just done there. And so the point of doing that would be because the properties in 3.2 tell us if we interchange rows, we just multiply our new determinant by -1. And so we interchange 2 rows, right? So we interchange these 2 and those 2, and so that was interchanging two rows twice, excuse me. So we're going to multiply by -1 twice. And this is now triangular, and so we can just multiply the diagonals together. And so there's 2 things here. This one means multiply the determinant by -1, and so does this. Those each mean you multiply the determinant by -1. And we know the determinant of a triangular matrix, I hope this makes sense. Determinant of a triangular matrix is the product of the diagonals. And so we just multiply the diagonals together and then multiply by -1 twice. And so the determinant of this one is going to be -1 times -1 times 3 times 4 times 2, which ends up being 24 again. Now, maybe, I don't know what, I'm happy to clarify something else, Sydney, but maybe you were trying to like put a 1 in the upper left-hand corner and actually get rid of the 4 in the upper right-hand corner or something like that. But I think that's sort of the easiest way to use those properties to make this one happen. Questions?
Would you be willing to just briefly go over the, because I know that you said that you could do row operations on a matrix, but if you did row operations, there was something that you had to do to the determinant. So
Yep.
I know that from multiplying, if you multiply a row by something, you have to multiply the resulting determinant by that. And if you interchange 2 rows, you have to multiply by -1. Oh, for addition, it just stays the same. Never mind. Okay.
Yeah, so if you just do like a normal row operation, like 3 times this row plus another row, that actually doesn't change the matrix. The things that change it, the determinant, I mean, the things that change the determinant are switching rows, or when you just multiply by a constant, but then don't undo it or something. And that's usually the confusing one, is the number C one, is when you multiply by a constant, especially the way that the book set up this formula. It's saying like the determinant of the new matrix is K times the old matrix. But most of the time, you want the determinant of the old matrix. And so if you want the determinant of the old matrix, you do 1 over K times the new one, right? Like the whole point of row reduction is so you can get the determinant of A by finding the determinant of B and making it easier. But then you just need to memorize or remember to divide by K in that case. And I did a couple examples of those in the notes, I believe. And I'll just remind you again, I'm going to try to remind you as much as possible, but there's also an example of this in the book homework, which we're not going to do, but I posted all those answers on Blackboard. So, if you get stuck on a problem on web work, I tried to recreate those homeworks from the book. So you can go back and maybe see if there's a similar one from the book or something like that. Anyway. Other thoughts or questions about this one? Or other questions in general. We finished this one. I'm happy to answer questions about this one, but if you have other questions, that would be fine too. Anything at all? Okay, I'll just say again, I'm going to post this page. I will take a snap pic of it and post it on Blackboard. I will post the video that we've just created on YouTube. And I am generally around for like homework questions and, questions throughout the day. But, if you're going to wait till the last minute to do the homework, you may be on your own.